Hello, welcome everyone. The talk is The Operation of a Main Station in Mars, presented by Julio and his team. You may proceed.
Okay, Jay, thanks so much for your introduction. I'm Professor Julio Rezende. Also, this was a co-creation with Varsha Shankar participation and also Varsha from Canada and Davi Souza from Brazil, okay? I'll be uh, starting this presentation about how would be the operation of a main station in Mars. And then, first of all, this is this proposition of the main habitat is a result from the Habitat Marte virtual missions, okay? But in reality, the Habitat Marte exists in the corner of South America. Here is a semi-arid area, or as a semi-arid landscape. And then here you can see the image of the station of Habitat Marte, the real station. This blue area is the greenhouse. And then in the next picture, it's possible to see one of our analog astronauts using the cooling system backpack, and also the landscapes with a lot of cactus, okay? And then we developed the presential activities, in situ activities here in Habitat Marte until March. And then happens the COVID-19. And then we stopped the presential missions. And then we developed the methodology of virtual missions, okay? And then based on the methodology of virtual missions, we had received participants from many parts of the world, as example of Varsha, co-author of this paper. And then actually it's happening the mission 52 from October 9th until 24th. And then we have participants from India, Brazil, Spain, and also Germany. And then as a result of this virtual mission, we had a participant from India. His name is Yashi Rato. And then she proposed the design of the station. In this station, we have 7 main facilities: the launch center, the main station, health facility, the greenhouse, sanitation center, engineering, and also the power station, okay? And then in this presentation, we'll be talking about the main station, how would be the operation of the main station. And then my presentation, I'll be discussing about 5 more important dimensions related to the operation of the main station. We'll be talking before the internal design aspects, also applied technologies to the main station, and management issues, some protocols, and some possible spin-offs to be applied to Earth. And then related to the first dimension, the internal design, we imagine the main station as an area that we can find some features like the control center, management, communication, also a dormitory, training room, dining room, kitchen, an area of gym, spa area, recreational area, also the research room, and also a small vertical garden with plants for meals. And okay, and then here you can see some possible photos or some concepts. An important concept is we'll be using the plants in vertical gardens, because the plants will be giving some element of nature to the inner areas. Also here we have the representation of some how would be the operation of the control center, also the research room, an area of dormitory, just to illustrate, and the kitchen. And then related to the kitchen operation, we found a technology called Mole, and then it's a robotic cooker, okay? And then you can see in the panel like a screen with someone present the guidelines related to the preparation of a meal. and then this would be an interesting technology to be applied in Earth, in Mars, sorry. And then also the dining room, we imagine the dining room as not big area, but be operating with part of the rotating the crew, okay? And then also gym area, and then we had a participant from one of our missions, a Brazilian student of architecture, and then she proposed something interesting. She proposed 3 different areas of hexagons, and then the first area would be the alpha area, and the second one the beta area, the third one is gamma area, okay? And then the alpha area is for the prolonged use as a silent sector, and is the destination is to rest. The second one is a medium use, is a social area and leisure sector. And the third one is for the scientific sector work, and they control the operation of the station. Okay. And then, okay, we can find in the alpha model some bedrooms, and also the study rooms, and also bath in the area, okay. And the beta model is we possible find the kitchen, the dining room, the living room. In the gamma model, the training, control, and research room here in this blue area. And then we imagined for the operation of this entire station, a population of around 24 or 28 astronauts in the entire station, okay? And then in the alpha model, we have 13 bunks, okay? And then also area to 26 luggage containers, also 2 bathrooms, okay? And the second one, the beta model, we are considering in ground level the kitchen, the second floor the living space, the third floor the gym, okay? And then this area, in terms of design, we imagine the structure using 3 levels, okay, 3 floors, and then this presenting 8 meters of diameter, okay, and then 9 meters of height. The gamma model is representing a ground floor, the research room, the second floor, the training room, and the third floor, a control center. And then I now be talking about the second dimension is the applied technologies. And then we can see some machines, technology necessary to the operation of the installation. Some possible machines and like the oven, fridge, virtual reality headsets, bathtubs, hydro massage, discotheque, communication technologies, and then a lot of things are in terms of entertainment and also work and in the destination to sleep is happening in the main station. And then we suppose that the main station will be the first facility or the first component to be installed in Mars, okay? And then after the installation of the main station, we have the installation of the other facilities, okay? And then some possible resources generated in situ or transported from Earth. We imagine that almost everything will be transported from Earth, and then also part of the food will be produced in the greenhouse. Okay. Now I will be talking about the third aspect. Is related to the management of the main station. And then imagine the 4 astronauts, the commander, the executive chief, the chef, and general assistant, okay? And then the commander, imagine a person with a multidisciplinary background, also someone from management or industrial engineering with high capacity of leadership and high personal resilience, okay? Also, we can see an imagine of the coronavirus spreading, and then we don't know what kind of situation will happen there, and then we need, the commander need to provide all the guidelines to avoid difficult situations. And then some duties are the control of the extravehicular activities, also propose routines and operational protocols, provide guidance to avoid risks, also sometimes conducting educational activities, also preparation for EVAs, also coordinate daily communication routine with NASA, ESA, ISRO, and other space agencies, also presenting communication with all the crew, with the facilities, and sometimes with specific individuals, okay? And then the second position is the executive chief. This person would be someone, an engineer or someone with an information technology backgrounds. And then some duties are monitoring all operations, keep all facilities running, monitor the routine maintenance, organize specific operations, coordinate trainings, okay? Organizing specific operations. And then the third position is the chef, okay? The chef would be a nutritionist, a cooker, or a cuisine chef. And then some duties are the define menu, the meals and food logistics, perform food preparation, waste disposal, cleaning, organization, maintenance, and repair procedures, assess the team's nutritional requirements, plan the availability of food, and define the field shifts, okay? And then this is the image of the character Neo from Thomas Anderson for Keanu Reeves during the movie The Matrix. And then in this image, he's inside the Nebuchadnezzar ship, and then he's eating oat, and then all days is the same meal. And then one of the challenge of the chef is prepare an interesting meal for the crew, okay? All days having something different, some related to pleasure. And then we can see here in the next figure space food, okay? And sometimes it's necessary add hot water to expand this kind of meal. And then in the last picture, you can see some lettuce, basil, and peppers collected in the greenhouse of Habitat Marte in Brazil, okay? And then it's very important. We have a nutritive and delicious meal for keep all the crew motivated, okay? And also permitting the nutrition of each astronaut. And then the last position is the assistant, and then this is interesting, a person from the fields of engineering, information technology. Sometimes is a person who emphasizes the well-being, create interesting content to entertain the team, and doing also food management, support the chef, coordinate organization of the dormitory, the gym, and also activities of well-being, managing the laboratory tools, study routines, and sample analysis, sometimes applying some psychological surveys. And then we imagine some possible training activities inside the stations. Inside the station, like some training are related to the new skills based in situations identified in Mars. Also systems operation, testing and training of new technologies, trainings related to the positions and tests of each astronaut, and also provide simulations. Then we select some videos to train astronauts. We imagine that in Mars they will be transporting some terabytes of videos and a lot of different content to entertain the crew there, okay? And then we select some videos related to the making teams work, how to manage your mental health, occupational safety and health, and also building resilience, okay? And then in Mars, we have like some terabytes of information related to these videos and also guidelines. And then also is important some resources for the 1 week, like the we have some data about the daily necessities, like water for drink, water for food, water for bath, and 1 kilo of food. Also, some guidelines from the main station to other facilities are related to provide guidelines to the mental well-being, daily routines, health occupation, also health, environment, and safety guidelines. And now we'll be talking about the fourth dimension of this presentation related to some protocols that we imagine, and then some specific protocols to be operating in the main station are the protocols for harmony, good relationships, and collaboration. Also protocols to deal with stress and relationship. Also infrastructure maintenance protocols, okay, in the main station. Then also we are imagining some protocols of health and safety. These protocols are related to hygiene protocols, also wearable data collection protocols using the Apple Watch or other wearables, identify the heart rate, calorie consumption, physical activities, and other samples. Also, some protocols to deal with the psychological emergencies, and protocols and simulations to deal with accidents. Other protocols related to occupancy and also entertainment. Some possible protocols to entertain the crew are related to some parties, some celebration days, or some national days, if you have a crew from different parts of the world. Also use of the board games and yoga and physical exercise protocols. Also the mindfulness activities, reading suggestions, and also suggestions of content to be consulted in Mars. And then also other protocol is related to micro production of food, the operation of vertical garden. This vertical garden is more complementary because we have other specific facility to produce the food. Is the greenhouse, okay? But we are considering the importance of in each facility we have a vertical garden, and then we have some ideas about some guidelines for the operation of this food area, protocol for cultivation, for maintenance and detection of some adjustments to collect the food, and also protocol for the rotation, disposal of the plants, best time for irrigation, male and female flower pollination, and also reflecting about the plant cycle and of each plant. Other protocol that we are considering is related to 3D printing. In these images, we can see some 3D printing using clay, okay, to produce a ceramic object. And then maybe in Mars we will be producing like some utensils, okay, like a ball or something like this, and also using plastic to be recycled plastic in Mars. And then also today Elon Musk mentioned the self-sustaining concept. Then we are considering the necessity to recycle all materials there, okay? And then we are providing some guidelines, like if you have if something broke there, we'll be using a protocol for the degradation of the product, like crushing of discarded items, preparation of pallets, the preparation of filaments for 3D printing and printing the objects. And then for this would be important have a great library of CAD design projects to be used to print different utensils, okay? And then the fifth dimension of this presentation is related to spin-offs. Is some technologies that would be transferred to Earth, okay? From the moment that we started the operation of the main station in Mars, okay? And then we believe that some possible activities that will be happening in Mars that will be applied to Earth would be related to some guidelines related to mental well-being, daily routines and guidelines, also health occupancy, also health environmental safety guidelines. Also, we imagined some possible impacts related to the Sustainable Development Goals, and then you can imagine that impacts related to the clean water, also related to the, in terms of safe energy, okay, in the main station. Also, it's very important, the goal 15 is related to life on land, is very connected with recycling. And then if you are recycling, we will have a less impact in Earth because we are recycling all the material, okay? And then this is my last information, my contact in Twitter. I'm a great user of Twitter, Julio FD Rezende. Also my Instagram is Julio Rezende. This is also my email. And now I finish my presentation and then I'm open to answer some questions, okay, and see some comments. Thanks so much for attention of everyone.
Aaron had a question. How did the multi-kitchen system work out for you? And can you give us an idea of the cost of the system?
Yes, I'd like to mention this is a real technology. It's a startup, I believe, but I'm returning to this slide. Okay, as this slide here, yes, it's a very interesting. It's molly.com, okay, and then it's possible to see all the information of this equipment, okay, in the website, and maybe send an email to them and have more information about the cost, okay, of this. Also, maybe they starting moment, they also looking for investors. And then I believe it's an interesting company to look and also consider these possible spin-offs from these technologies to be applied in the operation of Mars or Moon habitat, okay? Because it's not a good recommendation to have a intensive human intensive activities, and then it's very important we try to use the artificial intelligence, robots, and other machine learning to provide support to the crews in future Mars and Moon habitats. Okay.
Okay. There's no more questions in the chat. If anybody wants to unmute, we have 6 minutes.
Yes, I would like to invite, if part of the members here, if you like to be part of a virtual mission in Habitat Marte, okay, I will write my email here in the chat again. And then if you have interest to be part of a virtual mission, now we have more than 250 participants in the missions of Habitat Marte, and participants from more than 25 countries, okay? And then also we have a YouTube channel. The YouTube is also look for, the YouTube is very important for us because all the presentations done during the mission are available in our YouTube channel, is Habitat Marte, okay? And then you can see also the satisfaction of the members, because sometimes the people doesn't know how is the participation in a virtual mission. They have doubt about if we'll have a good result or not, or if possible have some learning. And then it's interesting to see a lot of videos in English the people explaining the learnings that they achieved during the virtual missions in Habitat Marte. And also during this moment of coronavirus times, it's more harder to be traveling around the world, okay? And now, since the beginning of the year, we from January to March were 6 missions, and then in the this moment of coronavirus were 20 missions done virtually. Okay, now is happening this mission 52. Okay, with participants from different countries, are 2 week 16 days mission. Okay, a virtual mission, and also having activities in almost all days. Okay, and then also it's interesting to us do a partnerships with schools and universities. And then if you have some possible member of a university or of or high school, please contact me, that we are interested to do this virtual mission with specific institutions. Okay, can be a class of a high school or of a career from a university. And then these virtual methodologies are very useful to receive the members of these different parts of the world. Okay, also the profile, the social media profile is Habitat Marte in Instagram, Twitter, Facebook, okay? Yeah, I believe the participants are satisfied with the topics.
On the Maru robot, how many cameras does it have?
I don't know. I don't have this detail, but if you write me an email, I can answer later. I would be looking this information and answer later with more detail about the Molly technology. Yes, but it's based in machine learning and also information technology, because if the software need to identify different tools in the table of the kitchen, and also identify some symbols, and that guides the combination of different different elements to prepare the food. Yes, but this is a very interesting technology.
Okay, we're about at the official ending time. Thank you for your presentation.
Okay, thanks so much, Jay. And then in this last slide is possible to see my contacts. Okay, thanks so much, and and a good event to all participants.
Thank you. Good night. I'm closing the room.
Okay.